Hello friends, today we'll see the analysis of the cables. Cables is one of the part of the mechanics where students never make the mistakes in the signs, means plus or minus something. So the reason is what? So cable is always a tensile element, means it is always tensile element. So that's why force in the cable is always tensile. Then simple steps are what? So in the cables example, very first step is what? Draw the free body diagram. Draw the free body diagram, and after that use the equilibrium conditions wisely. And those equilibrium conditions are what? Use summation fx, summation fy, and summation m equal to 0, means all this summation fx, summation fy, summation m is equal to 0 in an excellent way. And instead of explaining right in the beginning, I'll explain this with example only. And here what is there? See, loads are at B and C and it is supported at A. So first step in the cable segment is what? Or in the cables example is what? Draw the free body diagram. Drawing the free body diagram is very simple. And how in a simple way we can draw the free body diagram? Remove the support. Remove the support. And once you remove the support at A, as AB is tensile, means this AB is a tensile element. So the force will be like this, away from the joint. So AX is going to be away, and this AX is going to be also away from A, and AY is also going to be away from A. Means there is no chance of making any mistake in the direction. So it is going to be correct only. Similarly, CD is also, it is the tensile element. And if it is tensile element, this should be DX away from, and it is dy. So dx dy, these are the reaction components at A and D. So like this, in a simple way you have to draw the free body diagram. And once you draw the free body diagram, the speciality of this example is what? Both the supports A and D, they are at same level. Generally such type of example is being asked in the examination. So then carefully you observe the steps of solving this example. So very first step will be what? When supports are in same line or in level, so A and B, then in that case very first step is what? Consider whole cable, means this is the diagram of a BD of whole cable. For, so you can write for whole cable, correct? So take the moment either at A or D. Summation m, conditions of equilibrium, summation m about A, it is equal to 0. Because of this, what will happen? At A, AX, AY, and even though DX also it is passing through A, the moment will be 0. Then moment will be of 500 about A. It is going to be clockwise. 500 into 3 plus 400 into 7 plus 3, 10. And minus dy into 14. It is equal to 0. So like this, always we'll get the value of dy. One reaction will get. And how we can get it? Directly you can write that answer. 500 into 3 plus 400 into 10 divided by 14. 392.86. This will be 392.86. Means if we use one moment condition, we'll get one reaction component dy. Now if you use another equilibrium condition, summation Fy it is equal to 0. One more reaction you will get, and that will be what? AY upward plus dy. Plus dy means 392.86, and these two forces are downward, minus 500 minus 400, it is equal to 0. So from this we will get AY. AY is going to be 900 minus, it is 507.14. 507.14 means actually in the cables problem, always you concentrate on getting AX, AY, DX, dy. So out of that, easily we got dy and AY. So in all such example, we'll get in this way only. Then one more thing you can have from this whole free body diagram is what? If you use the third condition, summation fx is equal to 0, what will get? Minus AX plus DX, it is equal to 0. And from this, we'll get this relation, AX is equal to DX. Means X component of the reaction at A and B is same in this case. Let us consider this is equation 1. Always remember these steps. Consider whole cable, use summation M, will get one reaction. Then you use summation Fy, you will get another reaction. And if you use summation Fx, you will get the relation between two reaction components. Then after that, what is the step? So if we wish to get AX and DX, then always you have to follow this method. So that method is what? You take the section of the truss. So just I'll shift little bit. Now, so this B and C, the load is there, and this distance is known. This is treated as sag, SAG. One sag is known at B, and at C we don't know. So always cut this cable, means near to the known sag, I'll take the section like this. Means I'll cut this cable in this way. Let us consider this is 1-1 section. Section 1-1 means this cable we have divided into two parts, LHS, RHS, and this cable is always in tension. So this will be what? TBC. Then once we take the section, you have to consider LHS or RHS. Here there is no meaning in using the RHS portion because the sag is not known. Then we must know we must consider the LHS portion because the sag on that side is known. Consider LHS of section is that section line, cutting plane line 1, 1. And if you consider, means no need to draw the other sketch. From the same, you can consider LHS, RHS like that. And on left hand side, see now again, these are the forces. So if you take the moment at B, then easily we'll get AX. So the moment of TBC and 500 at B is 0. So we'll take the moment, summation M about B, it is equal to 0 in this LH left hand side portion. And the moment of AY is known, 507.14 into 3 minus the moment of AX anti-clockwise, AX into this sag is known. Now see the use of that sag, 4, it is equal to 0, and by this we'll get AX. And once we calculate this, that 507.14 into 3 divided by 4. It is 380.36. AX is 380.36 Newton. Means we got the third reaction components, and hence dx also from this equation 1, dx also 380.36. And in the cables example, once we get this 4 reaction component, almost problem is very simple. So your first target should be what? Get ax, ay, dx, dy. And after this, so whatever the question is being asked, easily we can answer this. Let us see what is the question. Question is what? Determine the support reaction and maximum tension in cable segment. Correct. First we'll answer this, and additional things also I wanted to tell. So support reaction. Support reaction means reaction component we have calculated. Over that also, again, if you really need the reaction directly, so these are the components, then what will be the reaction at A? Reaction at A will be under root ax square plus ay square. It is very simple. Ax is what? It is 380.36 square plus ay 507.14 square, and like this we'll get the reaction at A. Reaction at A, it's square plus 507.14 380.36 square plus 507.14 square, it is equal to, and its root. Make the calculations always twice and see the correctness. If you are solving the problem and calculations are wrong, then there is no meaning for it. 633.93. The reaction at A is 633.93 Newton. Correct. And RB will be what? Even though if you wish to get the angle at A, if it is asked, you can write theta A tan inverse of y by x. But I don't think that it is required. RB is going to be under root. Sorry. It is RD, reaction at D. It is going to be under root dx square plus dy square. And it is nothing but 380.36 square plus 507.14 square. 0.14 square, and RD, sorry, not 507, dy is different, 392.86. 392.86 square. From this we'll get RD, and this RD value is this RD value is 380.36 square plus 392.86 square, 546.82. RD is 546.82 Newton. And in the question what is asked, these are the reaction at supports RA and RD, and maximum tension in the cable segment. The maximum tension is always nearer to the support. Either it must be TAB or TCD. And see that whatever the reaction at A, that is the tension in AB, and whatever the reaction at D, it is the tension in CD, because this TCD is nothing but the resultant of these two forces, and that already we have calculated. That means from this, whatever the value is maximum, it is T max. And now in this case, I feel T max is 633, means at A. That segment is going to be TAB, and it is, this answer is 633.93 Newton. So this is whatever is asked in this problem. But again, I wish to add few questions on this. Easily we are having this solution, and how we can add that, just see it. If suppose the force in all the segment is asked, so AB, CD also we can calculate, that is, it is nothing but RD only, 546. But for getting the tension in this BC also, we'll have to calculate this value first, YC, sag at, or in the exam they may ask, find the sag at C also. Then in that case, what we have to do? The same cable, only we have to consider RHS. Now this is additional. Consider RHIS of 1, and then if we consider RHS of 1, if you take the moment at summation m about C, it is equal to 0. If we take the moment about this, directly we'll get this YC. How we'll get the YC? Because dx is known. Dx is 380.36. 380.36 into YC minus dy. Dy is 392.86. 392.86 into 4. It is equal to 0. From this, we will get YC. So it is going to be 392.86 into 4 divided by 380.36, 4.13. YC is 4.13 meters. Means in some questions only this may be asked. Then again, for getting this tension in BC, always I'll suggest, so what you have to do? So you should get this, its inclination. So this inclination or this angle, how we can get this angle? Just see it. So this angle theta or this angle theta. So for that we must know this distance. We must know this distance. Then only we can calculate. And for that we must know both the sags. Then how we can get this theta? So this theta will be what? Tan inverse of this. This will be what? YC minus this 4. Means 4 point tan inverse of 4.13 minus 4 divided by this span. So it is 7, and from this we'll get this angle. So actually this angle is going to be very small in this case. Tan inverse 0.13 divided by 7. 1.06, a very small angle. 1.06 degree. Correct. And once we know this angle, then anyway we have considered RHS. So this is TBC, or it is also TBC, the same thing. If we use summation fx, it is equal to 0 minus TBC. You can consider LHS side also, same answer will get. TBC cos 1.06 plus dx. Dx is what? 380.36. 380.36. It is equal to 0, and TBC is equal to the tension in the third segment. So that is going to be 380.36 divided by cos 1.06. 380.42. And again, one more observation I'll tell. So at the end of the complete solution of the cables example, if you see 3 cable segment, the tension near the support is always maximum. At A, it is maximum 633. At D, in CD, it is 546. And the tension in the middle segment is always least. And TBC, we are getting less than 633 and less than 546. So this is the detailed solution of the cables example. And I'll suggest use this method only instead of using Lami's theorem or something. Here I have used only equilibrium conditions, summation m, summation fx, and summation fy. Now we'll see another example of the cable where supports are they are not at same level. Level difference is there. So as usual, here also the first condition is what? Draw the free body diagram. Drawing the free body diagram, it's not difficult in the cables. So what we have to do? So remove the support. Remove the support, and there simply at A, it is AX horizontal and it is AY vertical, upward, away from it, because this is in tension. So direction, there will not be any problem in cable. Always will get the positive answers. dy dx. So this is what the free body diagram. This is what the free body diagram. Now this problem we cannot solve like earlier example or when supports are at same level. So here also I will give the hint. If we use like that, summation m about A, we'll get the equation in terms of dx dy. If we take the moment about D, again ax and ay, directly we'll never get the answer. Then here check where sag is known. Sag known means the vertical distance of a loading point. At B, this 7 meter is known. At C, this it is not completely known. Only this 4 meter is known, but completely not known. Then here, so what I'll suggest, so use this technique that, so instead of using whole cable first, you make use of this known sag, 7 meters first. Then for that, initially you will have to take the section of this cable. So this is the section of the cable. So again, I'll cut this cable like this. It's 1, 1. Cutting plane 1, 1. Now, if I cut this cable, so there will be completely 2 parts. Then we can consider this as TBC. This is also TBC. This is also TBC. Then, if we consider, see, when supports are at not same level, I'll suggest take the section first. Means consider left hand side of section 1, 1 first. Means we have taken that section first. And in the left hand side, what we'll get? AY into this distance is known, 4 meter. AY into 4. Before that, what we are supposed to do? Take the moment at B. Summation M about B. It is equal to 0. And when we are taking the moment about B, AY, vertical, horizontal distance, 4, minus AX into 7. It is equal to 0. Means we will be having the relation between AX and AY. So you can convert anything. So AX will be 4 by 7 AY. 4 by 7 AY. So see the procedure carefully. Here I am using initially the known sag. And now afterwards I'll consider the whole cable. Now consider whole cable. Same diagram, no additional diagram. If we consider the whole cable, now the relation between AX and AY known. Don't take the moment about A. Now you take the moment about D. So summation M about D, it is equal to 0. Then what I'll get? About D, the moment of AY. AY is it is vertical horizontal distance, 12 meters. AY into 12. AY into 12. And now instead of AX, what you will put? AX will be, its moment is anti-clockwise, minus 4. AX means 4 by 7 AY into that horizontal vertical distance is 4 minus 50 into 5 plus 3 8 minus 100 into 3. And now see what is the advantage of this. So this equation is only in terms of AY. Only it is in terms of AY. So first, so this term will be on right hand side. And what will be the term in the bracket? So it is 14 16 by 7 plus 16 by 7 minus 12. It is 9.71. It is 9.71 AY. So first we'll calculate 50 into 8 plus 100 into 3 divided by 9.71. 72.0709. So AY is going to be 72.09 Newton. This is one answer we got. Means by this way easily we can get by this method also. Our target should be AX, AY, DX, dy. Once we get AY, then what will be AX? Hence, AX will be what? Into 4 by 7. It is 41.19. So it is going to be AY. AX is going to be 41.19. 19. And now for the whole cable, if we use summation fx is equal to 0, if we use summation fx is equal to 0, then what we'll get? For summation fx minus ax, that we are knowing, plus dx minus 41.19 plus dx, it is equal to 0. Hence, we get dx is equal to 41.19 Newton. 41.19 Newton. And if we use summation fy, it is equal to 0. From summation fy it is equal to 0, what will get? Ay we are knowing 72.09 plus dy, which is unknown, minus 50 minus 100, it is equal to 0. Hence, we will get dy also. Means finally, we get the same things, dy. That 150 minus 72.09, it is 77.98. It is 77.91. Means this is whether supports are at same level or at different level. So initial step is getting ax, ay, dx, dy. Now we can answer anything. So here the tension in all the segments is asked. Then for that, first what I'll suggest, so once you are knowing this, at least tell the segment nearer to the supports. Means TAB and TCD, we can easily write TAB is going to be, directly I'll write, it is ax square plus ay square. Ax is what? Ax is 41.19. 41.19 square plus ay. Ay is 72.09. 72.09 square. Means this is the reaction at A as well as tension in AB. Whatever is asked in the paper, you can write. So it is 41.19 square plus 72.09 square, 83.02 or 03. 83.03 Newton. So this is TAB. Like this, TCD also. TCD is what? Under root dx square. Dx is 41.19 square and dy is what? 77.91 square. So TCD. TCD will be 41.19 square plus 77.91 square. 88.13. 88.13. And if in the problem maximum tension is asked, this is going to be maximum tension. Always it is nearer to the support. 88 is going to be the maximum tension in the cable segment. So now again this problem is not finished. So what they have asked in BC also, and for getting the BC, always we need this angle. So this angle theta, and how we'll get that angle, that also I'll explain. So for that, what we need, for getting this angle, we need this YC distance also. The sag means from this point to this distance. If this YC distance is not known, then we cannot calculate it. So for getting the YC distance, again the procedure is what? Consider RHS of this section 11. So whatever that section 11 is there, it's RHS portion. Then if we take the moment of C, summation m about C, it is equal to 0. Dx we are knowing. Dx is 41.19 into YC minus dy is 77.91 into this horizontal distance 3, it is equal to 0. From this we'll get YC, and this will be useful for getting the inclination. So 77.91 into 3 divided by 41.19, 5.67. So this distance is going to be 5.67. Now in the exam only this may be asked sometimes. Then how I will calculate this theta? See it very carefully. So I need this distance, this vertical distance, and that vertical distance, how I can get it? 4 plus YC minus 7. 4 plus YC minus 7 means actually this theta will be what? Theta will be tan inverse of 4 plus YC. YC means 5.67 minus this distance, means I'll get only this distance, minus 7 divided by this horizontal distance between B and C. So it is 5. So this will give us the angle. It is equal to 0. And how I'll get that angle? 9.67 minus 7 means this is 2.67 by 5. So it is going to be tan inverse of 2.67 divided by 5. It is going to be the angle 28.1. 28.1. This is the angle. And if I get the angle, then only what I have to do? So this inclination is same. So whatever this inclination is theta only. I'll use summation fx for this right hand side. Summation fx, it is equal to 0. This TBC, it is TBC cos theta minus TBC cos 28.1 plus this dx. Dx is what? 41.19. 41.19. It is equal to 0. And this will be TBC. And it must be less than TAB and TCD. Let's see what happens. So it is going to be 41.19 divided by cos 28.1. 28.1. So it is 46.69. It is 46.69. Correct. And now TAB is 83, TCD is 88, and TBC, this is the middle segment, always less than these two values. That means this answer is going to be 100% right. Means like this, without taking the tension, you have to solve the problem of cable, probably the easiest part of the mechanics. Thank you.